Alright, so what are functions? So as we can see on the graphic on the left here, functions are a type of relation. So going back to what you hopefully know already, a relation is a point made up of values, usually a domain, which is your x value, and a range, which is your y value. So a function is a relation used to represent the relationship between a set of inputs to an output. So equations are usually represented using f of x, and as you can see in the graphic, f of x does equal y. So looking at it from a perspective of inputs and outputs, an input usually represents your domain. So you've got your x value, and then an output usually represents the range, so your y value. So looking at this in terms of an equation, so let's just give a random equation such as f of x equals, let's just say x squared plus 2. So looking at the individual parts, we have the x within f of x, which represents your input, so you input that into the equation, and then the output represents this whole, let's do a different color for that, this whole thing here. So basically, since we know that f of x equals y, that's why this point here ends up resulting in the output of that. So technically f of x and y both represent the output of the equation. Now looking at a few examples using that equation there, let's just say x equals 3, for example. So we could write that as instead of f of x, we're going to write f of 3 because we're inputting the value of 3 here. And that will result in 3 squared plus 2, which we can just cram into space here, we'll evaluate to 9 plus 2, which equals 11. Pretty simple. And it's important to know that the f of x doesn't just have to be represented as f of x. You will sometimes see it in forms such as g of x, or if I really wanted to, I could write it as h of, maybe even h of a. However, the f of x is the most common just because it's quite a simple form that represents the input and output, but you may see some other examples elsewhere. So you might see these examples put into a table. So if I draw a table here like that, and we've got x and y, you can see that different x values, so for different inputs, let's just say we'll put some values along here, you'll get different y. So if we put in 0 into the function, we know we get 2. If we put in 1, we get 5. Put in 2, we get 6. And obviously, like we just did with 3, we end up getting 11. And so what we could do, just as an example of creating a graph using the x equals 3 example, is we can then graph these points. So the 3, the input, is the domain, and so that's in this case it's the x value. So along the x-axis we can put in, let's just say a 3 here, and then along the y-axis we will have an 11, so I'll put that a little bit higher up and label that 11, and then that will create a point that meets between those two of here. And so the graph of, so this equation that we put here will create a graph that looks a little bit like, let's just say that. And so, excuse my rough drawing, but the idea is that this point will be somewhere along that. And so with the table that we made here, all these points, all the x-axis points, all the different inputs will give outputs along the graph. And so this equation that we made earlier will represent how different inputs create a different output.